We'll be continuing on seeing the Mograph system and doing some different things in the Mograph system. And at the end of today, I'll be introducing you the first assignment that you'll get grades from. Okay, so actually in the past weeks, I've already shown you the tools that you need to be able to do your assignment. So actually you already have the necessary tools and knowledge. But for example, while listening to me this week, please ask any questions that you might have, because like if you don't understand some things, it will be very hard for you to do the assignment, okay? Although it might seem that we are simply adding different objects to the sidebar, the connection between those objects and how they function with each other is very important, and sometimes they can remain hidden at first glance. Okay, so let's continue seeing some other effectors, which one of my favorites was the shader effector. So shader effector is something like, for example, just you remember the displacer effector, displacer deformer. The displacer deformer was put on an object, and inside that there's a tab called shading, and this shading tab does displacements on that object's surface, right? Based on the image that we have here. So it's the same concept applies to the Mograph system. So we can use different textures to drive the animation of the Mograph system, okay? So I'll delete this. I'll add a cloner and cube object, scale this down with the scale tool by dragging in an empty space, then putting inside the cloner. I have immediate clones here, and I'll just increase the number of clones first. Okay, and then while the cloner is selected, I'll go to the Mograph menu, and through the effectors I'll add a shader effector. So as soon as I add that, you'll see that I'll just disable and enable this. As soon as I add this shader effector, the scale of the cubes increased, right? So as usual, when I add a new object, I can go to the attributes panel and start to investigate what properties there are. So one is effector tab, parameter tab, deformer, shading, and fields tab. Fields tab is, as usual, appearing in all of the effectors there. The plane effector, the random effector that we saw last week. So since this is the shader effector, I'll go and first investigate the parameters tab. So in the parameters tab, by default, the scale is selected. If I deselect this scale, you see that this is the property that increases the scale of these cubes. So if I increase that, you'll see that, for example, let's say 1. This means that it increases the clone's scale by 100%, like 1. Okay? But now this is applying to all of the clones. So I can deselect this and use it to activate the position, and if I increase or decrease, you'll see that everyone is affected from that. But what this shading does here is that the parameter that I select here, for example, moving the position in the y direction this much, like let's say 100 centimeters, instead of moving all of the clones, it will move only the clones that are based on the texture that I add here, the shader that I add here. By default, for example, I can again create a gradient, a noise effector, a noise shader, you see that it very much resembles the random effector, because this noise generated here is random noise, right? So if I click on that image, I can again play with the scale of the noise here. Notice that how the displacement becomes smoother when I increase the scale. So this is just for comparison. I'll add the displacer deformer to a sphere here, okay? And you'll see I'll scale that up and add this displacer to the sphere. And I'll add a shader to that displacer, the same noise or a similar noise. Okay, and now for now it's displacing it just a little because I increased the scale of the circle. This circle sphere is like 280 centimeters in radius, and this displacer is displacing only 10 centimeters from the surface. So I'll just increase that. Okay, so it displaces 90 centimeters. So now in the displacer, I'll go to the shading tab and click on the image here. Then I'll again play with the global scale. Okay, so I increase, and you see that how it becomes smoother. Okay, if I decrease it, what do I need to have this more detailed surface here? What should I do?
We should increase the segments.
Yes, exactly. So if I increase the segments of this sphere, you'll see that the details will become more visible on the surface. Okay. Again, I can go to the displacer and to the image, noise image, and increase the scale. So this is again smooth. If I increase the scale too much, this is again smoother. But more segments are needed if I decrease the noise scale, so that you see the difference. Okay. So this scale thing is very similar. Scaling that noise shader is very similar in this one. So I go to the shader. By the way, I'll just group them. So I created a null by clicking this button here. I double clicked this name, object's name, and let's name it cloner system. Okay. And I'll select all these things related to the cloner inside that null so that I can group them. Okay. So this sphere and this cloner system are separate things. So this I know by this hierarchy that this shader is related to this cloner thing. Okay, so let's see what happens if I play with the scale of the shader here. So if I decrease this too much, you see that it becomes all of the clones become randomly placed, not like a wave-like nature, but it's like a very spiky thing. So just to be more visible, I'll go to the shader parameter tab and increase this amount. So, and I'll go to the shading again, click on this, and increase the scale much. So you see that how smooth that is. So remember how we animated the displacer noise here? Who remembers how we animated the surface of this displacement sphere? Okay. How?
There was something like animation speed.
Yes, exactly. Where should it be?
In the displacer.
In the displacer, and since, yes?
In the shaders.
Okay. Yeah, there's animation speed here. So I'll just increase it up, and if I hit play, we'll see that it starts to move, right? So since this is the cloner system, shader effector has the same noise here, noise shader, I can do the same for this image also. So if I go to the shaders noise part, I can increase animation speed here. So let's see. I don't know why it doesn't move, but let's play with this. Okay, this should be moving if I increase the animation speed, but it's not working. So, okay, so there was an option. Probably, let me check. No. There is a property to update the animation, I guess, but I have to check that. Okay, so let's see which that property. Okay, so when I add, when I change the animation speed here, it does nothing even if I play this animation. But for it to update in real time, this is moving, but this is not moving. So I should go to the shader, and in the shading tab, there is this option called time dependent. So I should activate that. So when I activate that, you'll see that how they start to move according to the time. Okay. So now I can go and play with the scale of this noise. So I'll just increase the scale a lot. So you'll see that how smoother the surface starts to become, like a wave maybe. So since that I have this animation, I can go to the cloner again and increase the number to have a sea of moving cubes. Maybe. So if I, for example, get them closer to each other, maybe to like something like this, so you'll start to have a surface made out of cubes moving like this. Okay. So do this and let me see at each screen moving cubes like this, and then we'll continue on seeing different things, okay? So ask me if you have any questions. So from two different questions that I had, I realized that you are not aware, or some of you are not aware, for what property we are using this shader for. So actually in the shader, in the parameter tab, by default I said that it's affecting the scale, okay? It's 0.5 by default. And when you add the shader in the parameters tab, the scale is selected. So this means that this shader is scaling the clones by default. So if I hit play, you'll see that, okay, this is not so apparent, so I'll just decrease it. I'm exaggerating this so that you can understand that it's scaling things up and down. So let me make this even smaller. So now this system, this shader is scaling each clone, right? They are like breathing. But what I did was not disabling the scale, but enabling the position, right? So you didn't do that, so do that, and I can, of course, like use it to drive or move the positions of those clones, or scale them, or rotate them. So for rotation, for example, let's say I want to rotate them 90 degrees based on the image, noise image there. So this is not so visible, I guess. So let's increase them. So now you see that they are rotating 90 degrees based on that image. Okay, so now can everyone move their clones? So I'll show you another property of Cinema 4D in a while. So make sure that you have something like, let me scale this down. Let me increase the scale of this. Okay, like this. So when you hit play, make sure that you have some system working like this. Okay. So let me increase this so that it becomes like a plane with moving cubes like this. Okay. So we'll create a physics simulation in which a ball rolls around these moving cubes. I'll be showing you another property. So if your scene looks something like this, increase the scale of the cubes so that they barely touch each other, like this maybe, so that a ball won't fall down between those cubes. Okay. So I want everyone to be doing the same animation. Okay. And then I'll be showing some physics simulations and how that can be done by using cloners. So more or less all of you have this thing working, right? So I'll be showing you a new property, a new animation system in Cinema 4D, or like connecting things and adding functionality to your objects in your scene. So I'll pause this for now. I'll just introduce you that how that works, then pass on to this scene to create a simulation based on this object that we have. So I'll just create a new scene. I'll be creating a plane like this and add a cube and scale this down. Now I want if I hit play, nothing happens, right? Because like there's nothing that I have set up so that this scene, Cinema 4D, knows that it's a physics simulation. So for that, you can add tags. By the way, until now, is there anyone who hasn't signed this? Okay, sign, please. So if you hit right click an object on your objects panel, there are many tags that you can add onto an object. Okay, there are of course many other properties there, but we are interested in simulation tags. Okay. Diğer iki kişi daha imzaladı mı? İmzaladınız mı? So bayağı geç kaldın ya. Yani bayağı bir şey kaçtı. Late yaz, tamam. So if you right click an object, you'll see that there are simulation tags here. So I want this. There are two types of, mainly three types, but I want to add a rigid body tag to this cube since it's movable. And then as soon as I do that, you'll see that there is an icon created here. Okay, and if I hit this cube, the attributes panel has the cube's properties, but if I select this one, there are a whole bunch of new properties coming up, which is the dynamics, collision, mass, forces, and cache. Okay, so after I add this tag to this object, if I hit play, it crashes. Let's see. Okay, normally this shouldn't happen, but let's see. Okay, so it fell down. So as I hit play, you see that it starts to fall down. So it goes towards the infinity, but since the timeline finishes at 90 frames, it returns back to its original state. So now this scene, Cinema 4D, only accepts this as a dynamic object because we added the dynamics tag only to this object. So if I go and right click to this plane and hit the rigid body again, it adds the same tag to that object also. But now what will happen is they'll both start falling down. Okay, so what rigid body does is it says to Cinema 4D that okay, this is a moving object that will be affected from the gravity in your scene, but I don't want this, right? I want this to be movable and I want this to be static. So I want these two to collide with each other. For this to be static, I'll just right click and in the simulation tags, I'll select collider tag, okay? So when I do that, notice that it has a different icon here, and the properties are also different, like bounce, friction, sticking, and that kind of stuff. Okay, so when by the way, before starting your simulations, physics simulations, make sure that you hit this button or you are at the 0th frame, at the beginning frame, because the simulation calculations start from frame 0. So if I hit play, so you see that it starts to hit, okay? So for that simulation, the initial positions are important. For example, I can select this and rotate it into a different direction, maybe. So then I hit play, and it starts the simulation from that frame, okay? So for now, by the way, it doesn't bounce, right? Because this tag here, the collision tag, bounciness is 0. So I can make it, by the way, stop your simulation, take back to the 0th frame, and then change your properties. Let's say 40, and then hit play. So this is like not so realistic, so let's decrease that. Let's make it 10. Okay, hit play. And I want to see the simulation going on more. Okay, I want to increase the duration of my animation. So I can hit this 90F here, which determines the frames in your scene. Let's say this 300 frames. Okay. Notice that the timeline here changed to 300 frames. So then I rewind this to the 0th frame and hit play. And you see that how it bounces, and after some time it slows down. Okay? And okay, this is like bouncing too much, right? So I'll just stop the simulation, rewind it back, and maybe decrease it back to 3, and then hit play. And notice that after hitting to the ground, it slides, right? Because the friction is very low. So I increase the friction and rewind that. Maybe even make it 10. And rewind. You see that it stops, it doesn't slide back that much. Notice how these changes in the properties of the rigid body causes the changes in your animation. Okay. For example, if I increase stickiness a lot, and I hit rewind, and yeah, it's not so apparent maybe, but instead of a cube, I'll add a sphere. Okay, I'll scale it down, move it up, and I'll just copy this. I selected this tag and hit Command C or Control C, and then selected sphere and hit Command or Control V, and nothing happened. Okay, I can drag this tag to the sphere. Okay, and delete this cube. So I hit play. See? Now it also rolls. So if I change the orientation of this, you see that how it reacts to that. Sorry? Gravity merkezi, ya gravity sonsuzda gibi. Yani aşağı eksi y yönünde. So now you see how you can set up simulations. Let's play with the system that we already generated. Okay, so I'll return back to the scene that we've created. Okay, this one. So, and I'll just set up the scene and then we'll take a break. Okay, I'll create a sphere here, move it up, and in the sphere I'll add a rigid body. And which object should I add the collider tag? Sorry?
P.1.
So, yeah, okay. Which one? This one?
Yes.
This object. Okay, this one or this one?
This one.
This one. Okay, let's see will it work. So in the cloner system, I'll add a collider so that it's there. So I'll hit play. Okay, it didn't work. It passed through. So because I want this is a null actually. This is a group like think of it like a folder icon. But I want this tag to be related to the cloner itself. So I'll just drag that to that level. Or I can right click here, add simulation tags, add collider. Okay. So if I hit play, notice that how it slowed down. Yeah, it didn't pass through. So it's here. Okay, it's working. But it slowed down a lot because like it's calculating at each frame the collision between the sphere and all these cubes there. So I'll just increase the frame number to 300 and rewind. So think of it like a ball on a sea of cubes, maybe, I don't know. So, but it's so slow that it's not fun anymore. So I'll try to increase the performance by going to the cloner and changing the instance mode. Remember this, which allows you to increase the performance of your scene when you have many clones or computationally intensive systems. So I'll try these different modes because like they make it easier to calculate. So let's check render instance, rewind this animation and hit play. Okay, render instance doesn't work. It causes problems. So multi-instance, let's try that. Okay, so remember that I said that these can cause problems in some instances because like these two options simplify your setup into either less numbered objects or simpler geometries, or let's say like it doesn't take the physical properties of this system into account. So I cannot use this performance hack there. So I should use the instance mode. So what else I can do to increase the performance of this? Any suggestions?
Maybe increase the animation speed.
Yeah, actually, it won't change the playback amount. So
Maybe the bounce. Maybe we can increase the bounce of the ball.
bounce. Okay, let's change the bounciness to 6 and rewind this. It doesn't change it a lot.
So maybe we can increase the amount of the squares.
Amount of?
The squares.
Okay, that makes sense. I'll just, by the way, I just increased the bounciness to have it a more fun thing, maybe. But it seems not bouncing, right? So, by the way, I'm only setting the bounciness of the ball from here. If I want to set the bounciness value of the plane or the cubes, I should go here and add some bounce, increase the bounce there also. So I rewind this and let's see what happens. Okay, you said that we can decrease the number of clones there, which makes perfect sense because it will increase the performance by decreasing the necessary number of calculations. Yeah, it definitely helped, right? It's now a little bit faster. Okay, this bounce is too much, maybe. So let's decrease the bounce amount of cloner. So let's okay. So what else can we do to increase the performance? Do we need a very smooth sphere here? So maybe we don't. So maybe we can decrease the segment of the sphere, right? So for example, instead of 32, let's make it 11. It will also make it, actually it's not a dramatic increase in performance, but it definitely helps because like the number of polygons that will be calculated in the collisions will decrease. But this is like, let's say, increase it a little. So. Okay, let's take a 10 minutes break and then we can continue playing with this.